Okay, just a reminder that the second part of the test 2 is actually due today. So that's the programming part. Um, just let you know, the first part has, you already submit the first part, and you can check your grade for the first part, but the second part is due today. I believe it's at midnight today. So make sure you submit your second part of the test. Okay, let's start now. Um, I think last time we just started the derived class. So I'm not going to actually talk too much about this because the concept is the same as in Python. So when you actually learn Python, Python also has a derived class concept, and a derived class is a class that is derived from another class. Okay, it's a funny definition. So it's a derived from another class. But a derived class is actually derived from something called a base class. Okay, so the derived class itself is called a subclass, and the base class is called a superclass. Um, I believe I mentioned that the relationship between derived class and the base class is that the derived class is a specific type of base class. It's a subset of the base class. Okay, now what does that mean? So when we actually introduce the concept of derived class, it is actually based on this. Suppose I have a class, and I define this class as a person. Okay. So now, when you define a class called a person, so what kind of attributes or what kind of field variables we can define for the person?
How about name?
Yeah, you have a name,
Age.
last name, first name, right? And the age, gender. So you can define many different attributes. Now, suppose I want to actually define another class I called student. Now, if we try to figure out what's the relationship between student and a person, we know there's some kind of relationship, right? Student is a person. So, right? So, if
I mean, why wouldn't they be?
that's right. So, what does that mean in Java? Everything defined for person, like last name, first name, age, gender, also applies for the student. Okay. However, the opposite may not be true. So if I say a person is a student, that's not true, right? Student is a person, that's true, right? Student is a person. So, but opposite is not true. May not be true. So that means student is a special. It's a subset of a person. If we think about person as a set, student as another set. So student is a subset of person, right? So it's a special type of person. Person may include student, may include professor, may include software engineer, may include a designer. So
You could say that it's a role or a title.
well, sort of like this. So the person is a very big group. Now that includes student, professors, employees, software engineering, software engineer, a programmer. So each of these a special group of person, right? So we actually define that relationship, the subclass and the superclass, okay? Or we call it derived class and the base class. And student is a derived class of person. Now, based on this, the derived class say to inherit the property of base class. And this is called inheritance. Okay. So that means student inherits all the actually attributes defined in person. Okay. So inherits this. So you don't have to invent the wheel again, because if you define a class called a student, then you don't have to actually define all these lists. Java basically provide a kind of mechanism for you to do that. However, student may have some additional attributes, which are typically not seen in person. For example, if we can define another additional attributes besides last name, first name, age, gender, student may have a major, right? Student may also have a GPA. Okay. So you can have some variables that's a, that are that are only applicable for student, not for general person. Okay. So that relationship is called the inheritance. Um, the subclass, the derived class, and the base class relationship is something called is a relationship. It's called is a relationship. Okay. So an object declared of a derived class type has access to all the public member of the derived class as well as the public member of the base class. Now that's very important. Okay. Now everything in the student class, it can actually call the public method, public member of the derived class itself. So everything inside the student class can call any methods or any field variable, public field variable in the student class, but as well as the public member of the base class. Okay. So that means everything defined as a public member, it can also be accessed by a student. Okay. However, for any private member, like it's defined in person, you cannot access from student because it's a private member of the person. Okay. We can actually talk about this in an example. So now, as we say that the student is a derived class of a person, the base class person. Now, Java basically provide the syntax for this. In this particular example, I can say class student extends person. This basically defines the derived class. Student is a derived class of a person. Okay. Now student can inherit all the public member from person. And the student can also, access the public member of its own, or public or private member of its own class. Now inheritance has a couple of different types. There are various different inheritance variation. There's various different inheritance variations are possible. Now, first, a derived class can serve as base class for another class. Okay. So that means the inheritance you can create like something like a tree structure for the inheritance. So you have a base class here, and then you can have 3 derived class. And this derived class can also serve as a base class for another derived classes. And you can go on. And this derived class, this is a derived class of this base class, but this derived class can serve as another base class. Okay, so in this case, this one can be served as derived class for this base class, but this can be served as a superclass, okay, or base class of other derived class. Okay, so you can actually build the tree structure for the inheritance. That's one thing, and which also makes sense, right? So for example, if you can define a person, so you can define a student, and you can define professors, or you can define a designer, whatever. And then a student may have a derived class. I say CS student, CIS student. Okay. And you can have a math student, right? Okay. So you can actually just keep actually creating this tree structure, which is fine. And a class can serve as a base class for multiple derived class, which is actually true. So you have a base class, student is a base class of 3 derived class or more. So if you have a biology student, if you have a student in a history student or some other majors, so you may have a multiple derived classes. Okay, which makes sense, right? However, in Java, the opposite may not be true. A class can only be derived from one base class directly. Okay. So that means if you have a class, this class can be derived class of this base class. You cannot inherit another base class, another base class. You cannot have this. Okay. You cannot do this directly for Java. And that's called a multiple inheritance. Now, does multiple inheritance make sense? Does multiple inheritance make sense? It's probably the case, right? In some case, you can a particular class can inherit from different base classes. That's possible, in our real life. Our real life is more complicated than the life we actually build in using Java, right? Java is actually we have to set up a certain rule that you can do this, you cannot do this, like the base class and derived class. A derived class cannot directly have a multiple base class. That's a rule in Java. But in real life, that may not be the case. But we just realized that in Java, we cannot do that. Okay. One of the example is like, for example, I have a designer. Okay, a designer has a superclass called a person. A designer could also inheritance of the property from another class, maybe even like a student. Okay, so a designer could be a student. Okay, so a designer could inherit the attributes from student, and also, of course, it's also attributes uh, inherits the attributes from person. Now this is possible, okay, but Java does not support this. Okay. Now let's take a look at another case. The access by member of derived class. The members of the derived class have access to the public members of the base class. So okay, that's student. Okay, a person can let's say do something. And this is a public void. Sorry, it's kind of messy. Let me just make it a little bit cleaner. Let's see. Okay. Let's say public void do something. That's a method. Okay. Now in the student class, I can actually call this method because it's a public member of this method. And of course, any actually member of the student class can also call the member of its own method, right? So the student can, if there's a public method, say void take class. Okay, that's a method for student. So then I can actually call take class because it's a public member of the. I can even call private member of the student class because in the student class, I can even call the private member. But I can call the public members of the person, but not the private member of the person. So if the person is the base class of the student, I can only call public, but not the private member of the base class. Okay. Remember this. This is important. Okay. Now, also, so here, basically, based on different keyword, if a member is a private member, the private member can be accessible only by itself. So if I define a class called a bank account, and if balance is a private member of the bank account, so the balance can be called only inside the class bank account, not elsewhere. Even the subclass of bank account. If I define the subclass or derived class of a bank account, the derived class of bank account cannot directly call the balance because it's private member. Now, if it's public member, it's accessible by the member of class itself, also from the derived class, and also everyone else. Okay. Now, in some case, if there's no specifier, so that means neither it's a private nor it's a public, then in this case, we can use it's accessible by self, other classes in the same package. It's kind of semi-private, right? Now, we haven't mentioned much about the package yet. The package basically means You can interpret the package as just a folder. Now in the Microsoft Windows operating system, it's a folder. Okay. So in that folder, I can put in many files. And every files in that folder belongs to the same package. So you can interpret the package as just a folder. So that means if I have two classes, which is defined in the same folder, in the same package, and then it's, even though there's no specify, then I can still call each other because if there's no specify, a member is accessible by itself and the other classes in the same package. Okay. But if another class is defined, class is defined in another package, like in other folder of which is in the files in another folder, then you cannot access the members of the class in this package. Okay. However, Java actually provide another type of specifier or keyword. It's called protected. Protected is kind of in between. It's between the private and the public. Okay. It's less secure than private because private only can be accessible by itself. It's more secure than public because public can be accessible by everyone, self-derived class, and also any other class. Now, protected has some kind of limited access. Okay, so the protected is accessible by self, derived class, and the other class in the same package. See the difference here between public and the protected. Accessible by self, that's true. Derived class, that's true. And for public, it's everyone else. But for protected, it's only in the class in the same package, not in the different package. Okay, so the protected is a little bit more secure than the public. It still has a limited access. Actually, protected is actually initially defined for the derived classes. Okay. Now, also separate the keyword public in a class definition, like a public class, derived class, specifies a class's visibility in other class in the program. Okay. Now, I did not mention that, but when I give you some example, if you go back and check some of the examples we actually went through, you will find out sometimes I define a class called public class bank account. Okay, sometimes I define a class just called class, my class. Okay. Now in that case, there's no specify, there's no public over here. It's just to say class. Now what's the difference between these two? Now if I put the public before the class definition, public basically means a class can be used by every class in the program, regardless of the packages in which either is defined. So public has a wide access, so everyone in the program can access the public method in the public class. Now, if I don't say public class, I just say class, then that means a class can be used only in other class within the same package. Okay, so it's known as a package private. Now that's the difference. So if I just say class, then if I create the program, all the files for the programs are in the same package, then in that case, it really doesn't matter. I can put the public or with no specifier. It's basically the same. But only when I have a class, I create a program. The program contains many classes, and some classes are defined in this package, and some classes in the other package. If you want this class to be able to call each other, then you have to put the keyword public before the class definition. That's the differences. Okay. Now, so far, because in our class, all the examples are so simple, and all the classes in our examples are in the same package. So really, it doesn't make any difference whether you put the keyword public or not to put the keyword public. Then you don't see the difference. But if you actually, your class are actually distributed all over the different places in your computer, you have many different separate, you have a separate um, packages. Then if you still want to call each other, you need to put a public to make sure other people can see you. Okay. Now, one of the important thing to notice is when a derived class defines the member method. Okay. Now, derived class can use the public method of the base class, right? So the derived class can call the public method of the base class. Now, what happens if a derived class defines a member method that has the same name and the parameters as the base class method? So if the base class has a method called my function, which defines some parameter, and derived class also create a function, a method called my function, and with the same parameters, in that case, it's called a method overriding. Okay, in that case, the base class gonna override the, oh, I'm sorry, the derived class method gonna override the base class method. Just let me repeat this. If the base class defines the class member class method, which has the same name, same parameters as the base class, then the derived class method is going to override the base class method. Okay. Now, if you want to do the overriding for the base derived class, you had better put some kind of annotation here before the overriding method. It's called override. At override. This is going to actually remind the compiler, say, I define this method, and this method also show up in the base class, so I want to override this base method. Now, why you want to do this? Because typically, you always going to override the base method, the method in the base class. Why? Sometimes you don't have to, but in many cases, you may need to override the base class method. Okay, let me give you an example. Okay, later. Because a derived class may contains more variables. So even for the same action, the base class is more general. A derived class is more specific. Okay. So even though like something we're going to talk about it for the bank account. Okay. So this annotation at override is optional. Okay. But it's good practice. So I recommend that if you really want to override the base class method, you put this override at override annotation. Okay. Now let's actually take a look at the example. Okay. Now we're still gonna use the um, bank account example. Remember, we have a bank account, okay? We have a my account main, which contains the main method, okay? So now the bank account, in this previous example, we just define a bank account as a class. So we define the balance, we define the account owner, we define the account ID, and we define the method like a deposit, withdraw, and the transfer. We define the getter and the setter, right? Or sometimes called a mutator and the accessor. Okay. Now let's say, so in general, now in the example we just did, we can create an instance of an account, say my account, my savings account, my checking account, John's account. So these are all bank account. They should have the same attributes: the balance, the account owner, and also account ID. So at this time we haven't used account ID yet. Sorry. Uh, Now I want to make the bank account more specific. So I want to define a special type of account, bank account. One is called checking account. The other one is called a savings account, right? Okay. So not it. I want to define this because I find out the checking account is a bank account, so it should has a balance. It should has uh, account owner. But checking account is kind of special, you know. Checking account also in many bank they provide something called um, transaction count. Okay, so that means the reason people want to create the checking account versus the savings account is, for savings account, people are less likely to make a transaction. Mostly they have extra money. They want to put the money in the savings account because the savings account also gonna actually provide you some kind of interest rate. So if you put the money in the savings account, you're gonna actually gain some kind of interest based on the interest rate. Okay. So for example, if you put the money $1,000 in savings account, and the annual interest rate is 3%, and after a year, you will actually get some interest, which is 3% of interest, and 3% for 1,000 is $30. So after the year end, your balance will be $1,030. So you get $30 more for savings account. Now, if you really want to put your money in the savings account, but people just say, "Oh, savings account is still interest rate is kind of low. I want to put in the stock market, in the stock." True, you can get more in the stock, but you can lose your money in the stock. But for savings account, the interest rate is low, but you're guaranteed to have an interest rate once they set up an interest rate. Okay. Now checking account is different to usage for a different purpose. Now people create the checking account, so people normally create both accounts, checking account and savings account. But the savings account is for the money you want to actually put in here, and not going to make a lot of transactions. So now for checking account, you're probably going to write a check every month. You're going to actually pay your electrical bill. You're going to pay your water bill. You're going to pay uh, lots of bills. Okay, so normally you're going to write a check. So your checking account is basically used to make a transaction, to transfer the money to other account, or to pay the bills. You can make a deposit, you can withdraw the money. Okay. So, however, in many bank, they only allow people to have limited number of free transactions. Okay. So for example, you can actually make like a 5 transactions for free. But after you make a for every month, okay, you're allowed to make a 5 transactions. But after you actually exceed the number in a month, then we're going to charge you the transaction fee. Now, at the month end, so then we're going to check how many transactions you just made. If you just made like 10 transactions, and you're only allowed to have 5 free transactions, so you're going to pay for the additional 5 transactions, and then I'm going to charge you additional fee. Okay. Now, at the year end, I clean up everything, and then for the next month, you get another 5 free transactions. And if you use all 5 free transactions, and then for all the additional transactions, are we going to charge you a fee? So that's basically what we're going to do for the checking account. Savings account is fine. Okay. So let's do this. We want to create 2 classes. Okay. We want to create the 2 classes. So here's the bank account. Here's bank account. Okay. So now you have a balance. You have a account owner and account ID. And then we want to create checking account. And we want to create savings account. Savings account. Now for checkings account, now we still want to have balance account owner, account ID, right? Because the checkings account is a balance, is a bank account. But checkings account, we should also define account, transaction. Transaction count. Okay, I'm gonna define maybe a constant, say free transactions. And I can say every month you get 5 free transactions. And then after you exceed the number 5 transactions, and I'm gonna charge you the transaction fee, which is $5. Okay. Now, if you make any transaction like a deposit money, withdraw money, I'm gonna charge you $5 fee for this. Now that's only when you actually exceed the free transaction limit. Okay. For savings account, I'm gonna actually have an interest rate. Okay. Now let's take a look at this. So that's the checking account and the savings account I'm going to define as derived class of a bank account. So I don't have to invent the wheel. So I don't have to define the balance. Okay. Sorry, I just want to keep. Then let's check. So I can define a bank account, but I'm going to say checking account. Okay. .java. Okay. Now, so when I define the checking account, I'm going to define the checking account as, let's see. Okay, what am I gonna do? I'm going to say public class checking account and bank account, right? So I define a derived class, which is derived from the base class bank account. Okay, so then I'm going to define a private, okay, integer transaction count. Find the transaction count. Sorry, I don't know. So for some reason, my repel disappeared. Okay, so I just bring it back. Okay. So I define an integer, which is transaction count. Okay. And also I want to define two constant variable. One is the free transactions, the total number of free transactions. And the other one is transaction fee if they exceed the limitation. So I can define this as class method. Okay, public, static. I put that as a statical. Okay, and I use final. Remember the final. Final basically means a constant, right? Final, and it's an integer, free transaction. The transactions, and I put that as a file. Okay, and I have a private, static, final, double. I'm gonna say transaction fee. Enough if it's which is $5. Okay, and then what's the next? You're gonna define some methods. If you don't define any methods, then you're going to inherit all the public methods from the base class, right? But sometimes you want to override the base methods. Okay. If you in the checking account you want to do the deposit. If the deposit action is the same as base class, then you don't have to define deposit because you can just simply call deposit, and the Java going to basically call the deposit method in the base class. But if your deposit in the same checking account has some special operation, which is actually more than the base class can define, then you need to override this method. Okay, the first thing you need to override are the constructor, right? Okay. Now I can define a constructor, say public checking. Okay, constructor is going to use the same name as the class name. Okay, so for the default constructor checking account, can I use the default constructor of the superclass, the base class? Can I use the default constructor of the base class? So, let's say not a default class, but I can say my checking account. For my bank account, I need to provide my double initial amount, right? And also string owner. When I create a bank account, I can provide this initial active balance. Okay, and also the initial owner, the initial amount. So when I create the account, I provide my initial amount, and I also provide my owner information. But for checking account, I want to do the same thing. However, for the init amount, the initial amount will be added to the balance, right? And I did not define the balance here in checking account because I want to use the balance in the super class, in the base class. But base class, the balance is defined as a private, so I cannot directly set up a balance, say balance equals whatever. You cannot do this because the balance is a private member of the superclass. But you can call the constructor of the superclass to set the balance, right? Now, Java provides a particular keyword called super. Now, super basically means the superclass, which is bank account. Okay. And then in the superclass, we have a constructor called, we have a constructor called bank account, double balance, and the owner, right? So then you define the balance and you define the owner. Okay, here I can do the same thing. All right, I just erased that one. So you can call super for the initial amount, which is provided here. The init amount. And also, you can actually argument owner, which is provided here. Okay. And then I call super. That basically means bank account. And I provide init amount and owner. So that means which superclass constructor is called. The superclass constructor with two parameters is called, right? Okay. So that basically calls the superclass. Okay. Now the reason I want to override the superclass constructor is because in the constructor of the checking account, I'm not just setting up the balance and the owner. I also want to set up the transaction count. Okay, so initially, this transaction count should be set to 0, right? When I create my new checking account, the transaction count should be 0. And once I actually perform any action like a deposit or withdraw, I can increment the transaction, right? So that's why initially it's 0. That's one of the constructor, and I can define two other constructor. I can even define a default constructor here. And when I define the default constructor for the checking account, what the default account for the base account, the bank account actually does. For the default constructor, I set the balance to 0, set the owner to John Doe, right? Now, which can be done by simply call the default constructor of the superclass. I just say called default constructor of base class. Okay. So this way, I call superclass with no parameter. So this is the same as calling the default constructor here, the bank account. But in the derived class, I just use super instead of type bank account. I just use super. And then I can create another constructor. Where I can provide owner. Right? Now, in this case, I have a corresponding constructor in the superclass, and that constructor is just called the constructor with one parameter owner. And the transaction count is still set to 0 because that's only for the checking account, not for the general account. Okay. Now let's see. Anything else we need to define? Do we need to redefine the method like a deposit? Now in checking account, the deposit is gonna do the same thing, right? Just like a general bank account. The general bank account already defined the deposit. The deposit method basically just change the balance by adding the deposit amount, right? So it's very simple method. So I can, but here, when I do the deposit in the checking account, I can actually perform the deposit of the superclass, perform the deposit of the bank account. But what's more is I have to update the transaction count, right? So that's the reason why I need to override the correct spreading. Okay, let's see. When I use the override, yeah, I think it's correct. Okay, that's cool. So in the override, I just define my public void deposit. So double amount, right? So in the override, I still gonna perform the deposit in the superclass. Okay, so I still gonna actually using this super dot, but it's not the super bank account. I'm not calling the constructor. I'm calling the deposit in the superclass. So basically, the syntax I'm gonna use is a super dot deposit. I put the amount here. I call the deposit in the superclass in the base class. Okay, and also the reason I want to override the deposit is because I want to change the transaction, right? Transaction count. I'm gonna increment the transaction count because every extra deposit is gonna increment the transaction count. After a month, if the transaction count is more than 5, then we have to charge the money. And the same thing with the withdrawal, right? Let's see. And also for each withdrawal, the transaction count increment. Now, let's see what's the withdrawal actually defined in the bank account. In the bank account, the withdrawal, I need to check the withdrawal amount to make sure the withdrawal amount does not exceed the balance. So I need to actually return a Boolean. If the Boolean is true, that means the withdrawal is successful. If the Boolean is false, the withdrawal is still successful, but that means your withdrawal amount is more than the balance. So it only withdraw the balance amount. So now the balance is 0. So in here, so that means I also need to change the to Boolean, because you make sure when you do the override, then you make sure that everything you the withdrawal action method is exactly the same as the super class. Okay. So I'm gonna say Boolean I can say withdraw status. Okay. Withdraw status equals that after the withdrawal, and then the transaction increase, and then I need to return withdraw status. That's withdraw. Now, what else I need to change? I think that's probably okay, right? Let's see. Just compile it to see what happened. C my bank account main. This is working. So let's see the main method. Now in this case, every account is a bank account, but I want to create a special account. I call it checking account. So I'm gonna create a checking account. Okay, equals new checking account, and I can call. Let's see. I can provide the initial balance, say 1,000, and the name I call a constructor with 2 parameters. Say Mary Lou. Okay, so I create a checking account instead of general bank account. Okay, I create a checking account. So then, forget about the other things. So I can actually comment this information out. So now what I'm gonna do is I'm gonna call checking a checking account. So that's the checking account I've just created. That account the owner is Mary Lou, and deposited 1,000. Okay, so checking account to say get account info. Now let's compile again. Something's wrong. Oh, 30 in checking account 30. Looks like a withdrawal status. I just misspelled this. STATS. Okay. Java. My account owner is Mary Lou. Account balance is 1,000. Well, why this is the case? Now here's a checking account. So it's actually called a checking account. Okay. So, but I did not define get account info in my checking account class. But I can still call get account info. Why? Because get account info is the public member of the base class, right? So when I call a checking account dot get account info, even though get account info is not defined in the checking account, but it's still defined in the base class. I call the base class. Okay.
Would you want to eventually override that so you could, when you get the information, maybe it would tell you how many free transactions they have left?
That's correct. Because when I actually use the base account, get account info from the base account, it only provides a generic account information, not specifically for the checking account, because get account info actually can be called by any bank account, right? But for my checking account, if I want to show more information for my checking account, for example, for my checking account, I want to show the transaction count, for example. What's the current transaction count? Then get account info in the bank account will not show that information. So yes, I still want to override that information. Okay. Void get account info. So in this case, it's an override. So I need to put also I should put it in here. Put it in here. It's optional, okay? Because this makes the compiling job easier, because when the compiler see override, then compiler going to check, oh, I know what you want to do, you know. So let's see what's the get account info does in the bank account. So in the bank account, the get account info is basically print out account owner, account balance. Okay, that's fine. Let's go back. So I'm going to call super, because I still want the information provided by the base class is still okay, right? But it's not enough. So I can still call get super get account info. Call this to get the information. In addition, I want to add my additional information. Let's see, account balance. I'm gonna say transaction count is okay. My current transaction count. Okay. So let's do this. All right. Okay. So account owner, Mary Lou, account balance 1,000, transaction count is 0. Okay, that's okay. Now let's do this. So now if I show the get account info initially, then I'm gonna do my checking account deposit. Okay, I put the $10,000 here. So I put the deposit. So I call the deposit, which is also overwritten, override the base account, right? And then I call withdraw. $5,000. Okay. Now in between, I call the get account info to see what changed. Okay. I just call the get account info. Initially, I call get account info, and then I place a deposit and call get account info, and then I call get account info. Also, I think I should override the transfer, right? Because the transfer also can count as a transaction. So now the override is pretty simple. I call the super class transfer, the base class transfer, and then increment account. Okay. So, but so far I haven't override the transfer yet. So the transfer still don't count as a transaction at this moment. Now let's do this. Oh, I forgot the semicolon. So that's okay. This. I execute the. Okay, so you can see account owner Mary Lou, account balance 1,000, a transaction count is 0. And then the second time when I call this account info, the transaction count is 1. And the third time, the balance becomes 11,000, right? And the third time when I withdraw 5,000, so the account balance is 6,000 and the transaction count is 2. Okay. And then also, I want to create another new method, okay? Because I want to actually calculate the deduct fees. That's a new method, right? So that's a new method. Now, in which circumstance I need to deduct the fees? If the transaction count is greater than free transactions, right? Which is defined as 5. Free transaction is 5. If the transaction count is greater than free transaction, then I'm gonna calculate the fees. Okay, what's the fee? It's the transaction fee. It's a transaction fee, which is $5. Let's see, it's a transaction fee is $5, right? The $5, but right here, yeah, times transaction count, the count minus free transaction fees of free transactions. This is just a one. So if the transaction count is greater than transaction fees, that means the transaction count is more than 5. And then the fee is actually going to be transaction fee times transaction count minus 5, right? So that's the additional transactions. Okay. Now, once you calculate the transaction fees, then I will deduct that amount from your balance. So I'm going to call super withdraw super dot withdraw fees, right? Does that make sense? Because once I actually at the month end, I just calculate your total transaction, and I find out you have made like 12 transactions, and then I subtract the 5, which makes it 7. So 7 is additional transactions. I have to charge $5 for each transaction. So 5 times 7, that's $35. And then I'm going to deduct your $35 from your balance. Okay, so then I'm going to call withdraw. Okay, automatically call withdraw when I deduct the fee at the month end. And then after I've done this, I'm going to reset transaction count back to 0, right? Does it make sense? Because I already charged. So now you don't owe me anything. You still have 5 free transactions, and all the rules still can apply. Does that make sense? So that's the deduct fees. Okay. So this is basically the definition of the derived class. So I can, in most of time, it sounds like you need to override the member methods, because the derived class is a specific type of base class. So the most of time, the base class method may not accurately reflect the action of the derived class. So most of time, the derived class overrider method is gonna call the superclass method plus some additional operation for the derived class. Okay, so that's typically what you have to do. Okay, I think that's pretty much all I want to talk about for today. So I'm going to post these, the bank account information on the Blackboard, the superclass, the base class, the bank account class, which is actually already posted, but on the Blackboard. But now we have additional class defined. It's the derived class. Now, so far, all the class, all the actually like all the files are basically in the same folder. So if I on the right, if I check ls using the Linux command, you're gonna find out that my bank account.java, checking account.java, and my bank account main.java, they are all in the same folder. So that's the reason why they're in the same package. Okay. So that's the reason why when I actually create my checking account, I use public here. But if I don't use public, it's still going to work. My bank account, my bank account, I don't use public, right? Which is still okay, because my bank account, checking account, and my bank account main are all in the same package. So this is still going to work. So if I put public, they're going to make no differences. Okay. So I'm going to actually also add this, checking account on the Blackboard. So I hope that you can think about the savings account, create a derived class called a savings account, which extends the bank account to see what kind of actually variables you need to define, what kind of method you need to override or you need to create. Okay. Okay. So that's pretty much all I want to talk about for today. So do you have any questions? Okay, let me stop the recording.